to another Router Gods video. My name is Humphrey Chung, and in this video we're going to take a look at Practice Topology 3.1, and we're going to play around with some Cisco router load balancing. And the way we're going to do that is we're going to take our two routers, and you can see our topology here. It's our two routers, two loopbacks, and two fast Ethernet links. We're going to make static routes going from R1 to R2's loopback 0, and then we're going to make a mirroring static route coming back from loopback 2, or from router 2, going back to R1's loopback 0. One of the static routes is going to take the upper path of fast 0, 0. The other static route is going to take the lower path of fast 0, 1. And because both will be static routes going to the same place, it's going to be then up to the IPsef table to decide how to load balance. Now you might be thinking load balancing is pretty easy, right? You'll just load balance per packet. One packet's going to go up, one packet's going to go down. But as you'll see, it doesn't do that. And by default, it's going to work a little bit differently than what you thought it did, or what you thought it was supposed to work. So let's bring in router 1. All of our IP addresses are already configured. We just need to put in our static route. So it's going to be IP route. We're going to all twos. It's going to be a /32 mask going out fast 0, 0. And our next hop is going to be 10.10.12.2. Make our lives easier, we're going to hit the up arrow, change the fast 0, 0 to fast 0, 1, and change the 12 to a 13. Hit enter right there. Exit out, do a quick show IP route to verify that everything's good. And we have our static route in there, so that looks good. Going to go to R2. Going to add in our IP route. We're going to all ones from R2. It's going to be a /32 mask. Going out fast 0, 0. And our next hop is 10.10.12.1. Hit the up arrow. Change the 0, 0 to a 0, 1. And change the 12, 1 to a 13, 1. Do our quick verification, show IP route. And you can see there our static route going to loopback 0 of router 1. It's right there. Actually, it's right there. Those two lines. And it looks good. Okay, we go back to R1. Let's do a quick ping to make sure we have connectivity. So I'm going to ping loopback 0 and R2. That's good. Whoops. Looks like I had a debug on from previous video. So that's good. We're going to do ping of all twos from source loopback 0. And we have a good ping as well. Okay, so as you can guess, we're going to start some debugs. But before we do a debug, let's do a show IPsef table right there. Okay, whoa, IPsef not running. Well, we could start that. And now do a show IPsef. Okay, there we go. So here you can see the prefix of I want to go to all twos and a /32. I've got two choices right there. So that's pretty good. Let me just do the ping again to make sure that everything's kosher. All right, so now what I'm going to do is I am going to start a debug IP packet. I'm going to do a ping of all twos from the source loopback 0 and add in a command called repeat 1. So it's just going to send a single ping packet. Hit enter right there. And you can see that we have a source, comes from source of all ones, which is our loopback. It's trying to go to all twos. And the exit interface it took was fast 0, 1. And it actually came back on, looks like it came back on fast 0, 0. Okay. Hit the up arrow. Let's do the ping again. Let's see if it goes out the same or different interface. And you can see here it still went out of fast 0, 1. And let's do it a third time just to make sure everything is what we expect. Okay, so you can see here that we've pinged 3 separate times from the source of loopback 0, and it took the same interface. So we don't have any load balancing there. Now let's ping and erase the source loopback 0 and just do repeat 1. Okay, so you can see here that it is sending out fast 0, 0 right there. Let's do the ping again. Sending out fast 0, 0 and do the ping again. and it still sends out fast 00. So when we do the pings, we have a little different experience when we ping without the source loopback 0, but as you can see, it's not doing any load balancing, it's just continuing to send on the same interface. All right, let's see what happens if we disable IPsef. So conft no IPsef. And let's see what happens when we run the ping again. So we do this ping, and it sent out fast 00. So as you can see there, let's do one more ping. And look at that. Now we're sending out fast 01. And if we do the ping again, it should go out fast 00. Now, as you can see, it's flip-flopping back and forth on the pings. It is doing load balancing. Now, your processor is going to take a little bit of a hit because you've turned off IPsef, but maybe this is the outcome you want. Let's do the ping from the source loopback 0. You can see here it went out fast 01, and as you can guess, if I do the ping again, it's going to go out fast 00. Okay, so we know we can get this to ping. We can get this to load balance per packet by turning off IPsef, but that's probably not what we want. It's not very optimal. So I'm going to go to conft. We're going to turn IPsef back on. And just for sanity's sake, let's do a ping. You can see it goes out fast 01. We do a ping again, fast 01. So we're back to our normal behavior of not load balancing per packet. Okay, so now let's see if we can change it with a interface command. It's actually pretty cool. We go to conft, and we're going to go into interface fast 00, and we type in IP space, do a question mark, and somewhere in there, load sharing. Look at that. Style of load sharing. So we'll type in load, hit tab, load sharing, hit the question mark, and there we go. Per destination or per packet. I think I like per packet. IP load sharing per packet. And as you guessed, I probably have to go into fast 01. Do the same command, IP load sharing per packet. Exit out of there. And now let's see if we can ping. I'm going to ping from loopback 0. You can see that we are going out fast 01 on that ping. Hit the up arrow. We're still going out fast 01. And fast 01. Looks like it didn't do anything. Let's do a regular ping of all twos. Do a repeat of 1. Here we're going out fast 01. Hit the up arrow. Fast 01. Hit the up arrow. And fast 01. That really didn't do anything. Maybe we have to clear our IPsef. So clear IPsef question mark, and let's do star. Oops, looks like we have to add in some other stuff. Prefix statistics. Let's nuke that. And I'm going to do a clear IPsef, and you can actually enter the prefix, all twos right there. Prefix mask, we'll add in the all 255s. And looks like we have to add in the word prefix statistics. All right, do a show IPsef. We've got our entry there. Let's see if it works now. And incidentally, before we do the ping, we can actually do show IPsef, and you can actually type in the prefix, and it's going to give you a heck of a lot more information. So let's see, 000. You can see here that it's saying 0 because we just cleared the counters. And let's see what we got here. All right, so let's do the ping. The up arrow a whole bunch of times. So ping all twos, repeat 1. And it went out fast 01. Hit the up arrow. And now it's going out fast 00. Hit the up arrow again. Fast 01. So now it's flip-flopping back and forth on the direct ping. Let's do source loopback 0. And we've got fast 00, do the ping again, and it's going out fast 01. So you can see there that we did the IP load sharing per packet command on each interface, but to make it actually work, we had to kick it over by clearing out the IPsec prefix statistics, and just for good measure, we went in there and nuked it for the prefix that we wanted as well. So another thing just to end off with is, as you can see from our pings, so we're going out different interfaces. So there we're going out fast 00. Here we're going out fast 01. As you can see here, this is the interface that it's coming back on, fast 00. Let's see if it's taking a different interface on the round trip, on the return trip. Still fast 00. And it's still fast 00. So the reason for this is that the other side, it is still operating on the per destination load balancing. It's not flip-flopping back and forth. If you wanted to make the return trip load balance, what you would have to do is set the IP load sharing per packet command on each interface and then kick over IPsec. Alright, so that was a nice video, hopefully a nice video on playing around with load balancing on a Cisco router with static routes. Thanks for watching.